Get your free copy of the complete tutorial at www.teachucomp.com/free.
In the previous lesson, the term relational database was used. So what does the term relational mean, and how is this important? The term relational describes the method used for storing data within the database tables. However, it may be easier to understand the relational model of data storage by contrasting it with another method of storage that you may be more familiar with. That method would be the flat file method. Information is frequently stored in large flat files. For example, assume that you want to create a database file that stores your company's customer information. You would begin by listing the different attributes of the customers that you wish to record. You may want to record customer information like the first name, the last name, the company name, and other relevant pieces of information. Perhaps you could create a table in an application like Microsoft Excel where you can create columns for each piece of information that you wish to record. You can then list each customer's information in the rows underneath the columns, creating a basic table. So assume it looks like the following example. Now, for many types of databases, the structure shown on screen would work well. This is a flat file list or table. What you're doing when you're using this type of database is you're recording a single piece of information, like the first name, last name, or address about a single entity, in this case, a customer. The reason that this type of data structure works well in the example given is because for each entity or subject, meaning the customer, you are only recording information that has a one-to-one relationship to that entity. So what does this one-to-one relationship between the entity, the customer, and the data that you're recording, such as first name and last name, mean? What this means is that for each entity or subject, so in this case the customer, you're only recording information about that entity for which there is only one answer. For example, each customer would only have one first name and one last name. They only work for one company. So the term one-to-one really refers to the relationship between the subject of the table, which is the customers, and the data being collected about that entity. Because for each one customer, there's only one possible piece of data to record within each column, the relationship between the data in the table and the subject of the table is one-to-one. Now, if this is the type of database that you're trying to create, then simple Microsoft Excel tables will work very well. The problem occurs when you try to use a flat file approach to model a more complex entity or subject, such as sales. For example, assume that you wanted to expand the customer database from the flat file database that's shown to also include sales data. Now, in addition to the information already being collected, you also want to record each customer sale. First, you would start by listing what data about each sale you want to record. Keeping the example simple, assume that you decide to record the sale date, the items purchased, the quantity of items purchased, and the amount paid for each item. You may decide to add the additional columns to the flat file structure to record that information. Now, this may appear to work at first glance. However, you will immediately begin to encounter problems when you begin to enter records into this file. So to begin with, each time a customer makes a purchase, you must re-enter all of the duplicated first name and last name information again. This alone is irritating enough. However, you will also soon run into another problem. What do you do when a customer purchases multiple items in an order? One solution often proposed at this point is to enter another row with all of the redundant customer information for every item purchased. However, you'll find that this will cause the file to grow quite quickly downward. And you'll also have to enter a lot of redundant customer data for every single item that's purchased. This is not an elegant solution and will inevitably waste storage space as well as the time and effort of the person who performs data entry. Another solution often proposed at this point is to create additional columns, such as Item 1, Item 2, Item 3, Quantity 1, Quantity 2, Quantity 3, and so on. And doing that instead of having to enter additional rows of information. While that may initially seem like a good alternate solution, you then have to consider what will you do when someone purchases 100 items. Will you really create a set of 3 columns, such as item, quantity, and amount, for each item purchased, producing a single table over 300 columns across? Would you simply leave them blank if the person orders only one item, wasting valuable storage space? In this solution, you're actually simply substituting columnar growth or growth across for vertical growth or growth down. So that's not really an elegant solution either. So why is there a problem now when there wasn't one earlier? And the answer is that you are no longer trying to model a one-to-one data relationship within a single table. Recording sales information is simply more complex than recording customer information. What you're trying to record now is what is referred to as a one-to-many relationship. Basically, for each entity, meaning one customer, you're now trying to record data in the columns, which could occur more than once per customer, meaning the items ordered. You would be in a sorry state if each customer could only purchase a single item. So you must allow for the fact that within a sale, each or one customer may order many items. The relationship between customers and items purchased is a one-to-many relationship. When you find that you're trying to model a one-to-many relationship, it's then that you must abandon the flat file method of data storage, where you try to place all of the information that you want to record into a single table, and instead turn to the relational model of data storage for the solution.
Like what you see? Pick up your free copy of the complete tutorial at www.teachucomp.com/free.